So our goal today is we are going to be completing the square in order to get vertex form. So basically what we're trying to do is this. All of last week we looked at that if I gave you a quadratic that was written in this form, which is called vertex or graphing form, it was really helpful. And the reason was because we could identify our transformations, P, H, D, R, V, and from those transformations we could then graph our equation. Our question today is, okay, this form of our equation is really helpful, but what happens when we start with standard form? We still have strategies that we can use. But what if there was a way where we could go from standard form, ax squared plus bx plus c, and turn it into graphing or vertex form? And that's what we're going to be taking a look at today. We're going to be looking at one strategy of how we can take this equation on the left and manipulate it using some algebra tricks to get this equation on the right. Okay? And as the title hints at, we're going to be using a strategy called completing the square, which you might remember from last year. I want to give you a tiny refresher of that. Completing the square is a strategy for when we're trying to solve for x. So as an aside, suppose you were given the following equation to solve, and you were asked to find x squared plus 6x plus 13 equals 0. Now, if we were simply asked to find that equation right there, our going strategy would be to factor and solve. But when you come to this problem, you'd come over to 13, and the only pair of numbers that multiply to 13 is 1 and 13, and unfortunately, these are never going to add to 6. So this is a problem that is not factorable. Now, it might still have solutions or x-intercepts, but it is not factorable. One strategy that we had last year was to do the following. I'm going to take my 13 and move it to the other side. And so I'm going to get x squared plus 6x is equal to a negative 13. Okay, just subtracting 13 to both sides. And one of the strategies we had was to do what's called complete the square, and in essence, pick the number that will make the left-hand side factorable. And the reason we call it complete the square is visually, if we think about the algebra tiles, if you have an x squared tile, if I throw an x on one side, an x on the other, and I repeat this, not the best at drawing, bear with me, until I have used all 6 x's, 1, 2, 3, 4, 5, 6, we in essence have completed a square. So the whole reason it's called completing the square is because you are literally making a square with your equation. And what this little diagram is hinting at is that the best number I could plug into this spot right here would be the number 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have a plus 9 right there, then this side is going to factor nicely. Okay? Now, unfortunately, if I add a 9 to one side, I have to add it to the other. Okay? And I could continue this on down. I could factor the left-hand side, I can take the square root, I can do some simplifying, and I could solve for x. This is the core of what we're going to be using today. But it's going to look a little different because we are, instead of solving for x, we are changing the equation. And I want you to remember right here how we added the same number to both sides, because that's going to be important later. Okay? So let's jump into our first official example. Suppose I asked you to change the following: y equals x squared plus 8x equal to 10, sorry, plus 10. And I want you to write it in vertex form. We want to take this equation that's in standard form and we want to turn it into vertex form so that we can graph it more easily. So here's the way I'm going to start. Some of these steps are going to seem a little bit extra, and that's just because they're giving us strategies that we'll get to use later on. I'm going to start by putting parentheses around these first two terms. If there were a number in front of x squared, I would need to pull that out. We'll see that in the next example. Otherwise, I need to figure out the number that's going to make this part in parentheses factor nicely. And if you look at the example before, look at what happens. 6 meant that we had 3 on one side, 3 on the other. So we cut the 6 in half. And then, in order to figure out how many of these single tiles we needed, we went 3 times 3. So all I'm going to do right here is the following. I'm going to take the number in front of x, the number 8. I'm going to divide it by 2. Always divide by 2 because I have one side and a second side. And so by dividing that, I end up with the number 4. Now, in order to figure out how many single pieces I need to square that 4. And so I end up with 16. That is to say that if I plug a 16 in these parentheses, I get an expression that factors nicely, which means I now have the following. Y is equal to x squared plus 8x plus 16 and the plus 10 on the outside. And here's where our challenge is. I just added a plus 16 into this equation. And Algebra 101 says that I can't do that to only one side. Whatever I do to one side, I have to do to the other. But what's different with what we're doing right now is my other side is just the y equals. And I don't really want to change that right now. So in order to not change my equation but still get this plus 16, I'm going to throw in a minus 16. And the reason this works is this. Think about what these two terms are saying. Add 16, subtract 16. Well, those cancel out and it's just 0. So in essence, I'm plugging in a fancy looking 0. The reason this is helpful is this. Take a look at what happens. If I focus just on the first 3 terms, x squared plus 8x plus 16. Well, let's consider factoring that for a second. I need 2 numbers that multiply to 16 and add to 8. And those 2 numbers for factoring are 4 times 4, right? 4 times 4 is 16. 4 plus 4 is 8. So this first 3 terms is really x plus 4 times x plus 4. And the rest is just going to come straight down. My minus 16 comes down, my plus 10, and for right now I'll even keep my parentheses. If I then take this step, I can clean it up a little bit. X plus 4 is really x plus 4 squared, because I have 2 of them multiplied together. The minus 16 comes straight down. The plus 10 comes straight down, and this cleans up to be y equals x plus 4 squared minus 6. Minus 16 plus 10 is a minus 6. And so what this means is this part that I boxed, that you can't see, but now you can. Y equals x plus 4 squared minus 6. This part in the box is the same equation as what we started with, x squared plus 8x plus 10. Grab a graphing calculator, plug them both in, and you'll notice that they trace on top of each other. They're the same equation. But all we did was manipulate some of the algebra in order to get them into the form that we wanted. We start with the first two terms, use the part in front of x, divide it by 2, square it to get the perfect number so that we factor nicely. But because we can't just add that number, we have to add and subtract. First three terms factor down, the rest stays along for the ride, and we get our final answer. We're going to take a look at one more, and this time I'm going to throw a 2 in front. So let's go on to example 2. So same idea, but consider this. Y equals 2x squared plus 20x plus 11. Okay? Same idea. We want to turn this into vertex or graphing form. But we've got this 2 in front, and that's going to come into play. So I'm going to start same as before. I'm going to put parentheses around the first two terms. Where this problem is different is in this step. In order to complete the square easily, I need this to just be an x squared, nothing more. So in order to make this an x squared, I'm going to pull the 2 out in front. And when I pull that 2 out in front, this first term becomes x squared. 2 times x squared is 2x squared. And the second term, when I pull the 2 out, means that this is going to become a 10x. Because 2 times 10 gives me 20. So with that in mind, I take the number in front of x, 10, I divide by 2, I get 5, I square that 5, and I get 25. So my perfect number is the number 25. So I'm going to take a moment, and just like before, 2x squared plus 10x. In order to make this factor nicely, I'm going to take my 25 and I'm going to add 25. But I can't just add that 25 without changing my equation. So to keep it balanced, I'm also going to subtract 25. And then finally, the plus 11 is just along for the ride. So remember, this plus 25 minus 25 is essentially a fancy 0. Now, here's where we're at. We need to take these first three terms and factor. Two numbers that multiply to 25 and add to 10. Well, those numbers are going to be 5 times 5. Because 5 times 5 is 25 and 5 plus 5 is 10. So this problem factors into y equals 2 times. Now this is going to be x plus 5, x plus 5. I'm going to go ahead and group that up. And I'm going to write x plus 5 squared, just like we had before. The minus 25 comes straight down, and the plus 11 comes straight down. Here's the part where it gets a little tricky. This 2 in front, in order to clean this up so that it looks like vertex form, we're going to do the following. See how I have two sets of parentheses? I have the big pair on the outside and this little pair around my square. Well, this 2 needs to distribute to each part in my parentheses. Okay? So when I do that, I get the following. Y equals 2, parentheses, x plus 5 squared. 2 times a minus 25 is a minus 50 plus 11. And then finally I can clean that up by adding the last two terms, x plus 5 squared minus 39. The two biggest challenges I see with these problems are this. One, when you start, let's zoom out. I'll just move this up a little. When you start and you pull this 2 out, figuring out what number goes in front of x. A lot of times we mess up there, so always just double check. So right here, I pulled a 2 out and I double check. 2 times 10 is 20. Okay, we're good. So that's the first part. The last part is down here. You forget to send the 2 back to both pieces. It doesn't just go in front of the x plus 5 squared, but it also has to come over to this 25. As a final little hint before I give you a few practice problems, this part where we factored and we got x plus 5 squared, notice when we divided by 2 and got 5, that's the number that's in my parentheses. It's always going to be that way. That's the way these problems work out, and that trend will continue. So what I'm going to do at this point is I'm going to put 3 problems down that I want you to try. You can work with your group and try all 3. You can complete one and then check the video solution. For each of the video solutions, I'll give you the answer at the beginning. So then that way, if you already have it right, you can decide whether or not you want to watch the solution. That's your choice. But I will work out the solution as well. When you finish the 3 practice problems and have checked your answers or watched the videos, there will be a practice page with the substitute for you to give a try as well. So these 3 are the following. So you try. Write these down. Take a moment and give each one a try. So problem A, y equals -3, x squared plus 18x plus 5. B, y equals 1/2 x squared plus 6x plus 10. And C, y equals 2x squared plus 10x minus 4. So give those 3 a try. I just realized that page wasn't up, but there you go. Give those 3 a try. Feel free to work with your group. Feel free to work independently. Again, either check after each one or check after all 3. The solutions are posted below. Hopefully this works out and we have a general idea of what's going on.